Can I continue where I left off? I want to make this one really quick, so I'm just going to get right into it. So there's different types of growth: arithmetic, geometric, exponential, and then there's logistic. So I'm really just want to focus on geometric growth. So arithmetic growth means there's no change in the growth rate. It's continuous. Okay, so every year there's 10 more budgies born. Geometric growth rate is where there's a continuous, but it's based on a percentage. So there's like, say, a 10% growth rate. And so even though this looks like it's like an exponential curve, it's not. It's a geometric growth rate. Okay, so it's increasing at the same continuous rate. But when you add 10% every year, that 10% value is higher. So like 10% of 100 is only 10, but 10% of 1,000 is 100. So that's what this growth curve here is showing. And that's geometric growth rate. So this is the part that I was saying is kind of like when you're looking at compounded interest. So like you have 5% returns on a mutual fund every year. You're going to see that it's toward, as the amount of money builds up, it's going to get bigger and bigger. Exponential growth rate is quite different. An exponential growth rate is when the growth rate itself is increasing. So it's 10% one year, maybe it's 15% the next year, then 20%. And so that is where the growth rate continues to increase as the population increases. Okay, so that's what I kind of wanted to show you with these graphs. Now, this is the part that I really wanted to focus on, which are how we calculate geometric growth. Okay, so this is best illustrated by looking at an example. Okay, so when we're looking at growth rate, we use the symbol lambda. Okay, the Greek symbol lambda represents growth rate. The population size at the first year is in the denominator, and then the numerator it's the new population size. So if we look at this example right here, population of Holy Trinity was 700 in the first year. That goes down in the bottom. Okay, that's n at time t. 300 students transferred in and 31 students transferred out. So if you take the 700 students, you add 300 students, you take away 31 students, that is your n plus t1. So a year after the 700, in the second year, there was whatever that is, like 1,000 minus 31. So 669. When you calculate that out, the growth rate is 1.38. So what that means is the growth rate for that first year is 38%. The school grew by 38%. Okay, you have the 1 in front because it stays at 700, and then you gain 38%. Okay, so it'd be similar if you're calculating compounded interest. At 5% returns, it'd be 1.05. Okay, so now let's say we're going to assume that the school is it's not realistic at all, but we're going to assume that the school is constantly growing at a rate of 38% increase every single year. So in the second year is 38%, in the third year is another 38% on top of that, and so on and so forth. So in order to do that calculation, this is where it gets a bit confusing. So the initial population is the n at time 0, and that's the 700. Okay, so that was at the start of this 5 years, we had 700 students. So the 700 is going to go there. We've calculated the growth rate as 1.38. That goes here. And the t, to the power of t, that is the 1.38. So we're assuming that for each of those 5 years, every one of those 5 years, there's an increase in 38%. So 700 times 1.38 to the power of 5. Okay, and that means that after 5 years, if the growth rate stayed the same, was a constant growth rate of 38%, we'd have 3,503 students. Okay, again, not a realistic example at all, but it just gives you an idea. So just knowing how these two formulas work. Now, traditionally, if we were going to have an exam, which I don't know if we will be having an exam, I don't know. I don't even want to make a comment because I don't want to sway you either way, because depending on until we hear anything from the board. But if we had an exam, there would be a question like this on the exam. So the city of Mississauga, so here's one more example. The city of Mississauga has a geometric growth rate of 16.7%. So that means every year that city grows by 16.7%. If the population in 2003 was 612,960, what would the population be in 2004? So first you have to do is put this percentage into a growth rate. So the lambda is going to be 1.167. So that's that 16.7 right there. Okay. We don't know. We know what the population size is now this is the next year. So you're using that initial formula to calculate it out. And you get a population of 715,324. So that's using this formula right here. Okay. Now, let's say we want to know it after 10 years, assuming it's continuing to grow at 16.7%. So that's where we use the second formula. So 1.167 to the power of 10, because t is represented by 10. And the initial population was 612,000. You multiply that out, and that's what your answer is. Okay, so what I want you to do now is do this right here, and that will be it for this lesson. I will be posting one last thing, and I realize it's probably going to exceed the 3-hour limit. I'm anticipating the 2 parts that I've already posted on them. Google Classroom will take you about 2 hours. It might take you a bit longer. Please let me know if it does take you longer, especially if it takes you significantly longer, because I will adjust what I post next week. But I want to post the last part of this unit today as well. So I'm going to do that as an appendum, but know that I will adjust how much time you spend next week. So I anticipate maybe this week's worth of work that I'll be finished posting today will take you around 4 hours. You do not have to do all 4 hours this week. Know that some of it's going to bleed over into next week. And then on next Tuesday, I will post some more stuff, but I'll keep it to within the 2-hour limit. Okay, thanks.